Right, hello. This is a video on arithmetic sequences at a kind of AS level. Okay, so I'd recommend going through this to attempt the questions before you kind of carry on watching. Okay, so the first thing I want you to have a go at is thinking about what would be the sum of all the numbers from 1 up to 100 and how could you do this in a quick way. So this is something that was famously asked of Gauss, who's a famous mathematician, and apparently his teacher asked him what it was to shut him up because he was always doing the work too quickly, and he straight away said, well, the answer is 5050. And the way he did it, if this is true at all, was he imagined the numbers being written backwards below it, and then what would the sum of both of these sequences be, and then seeing that each term would be 101. So if we've got 100 terms of 101, that means in total we've got 10,100, but we've obviously counted every single term twice, so the answer would be that divided by 2, which is 5050. So this kind of thinking is going to help us when we go on to come up with a formula for the sum of an arithmetic sequence. So before we get stuck into that, just some definitions and notation and things. So at its kind of most basic level, a sequence is literally just a set of anything really in a given order, and a series is that added up. So you can see here 2, 5, 8, 11, 14 is a sequence, but 2 plus 5 plus 8, etc. is a series. Okay, the way this is notated, the kind of kth term, if you like, of a sequence is UK. So, for example, that should be a U here. If you have the 17th term of a sequence, that would be U17. Some other formula you might run into, some notation, sorry, is this sigma notation. So this, what this literally means, this part is the sum from when k is 1 up to k is 4 of then whatever's here, so UK. So in this case it would be U1 plus U2 plus U3 plus U4. Okay, it's a bit like integration, but for kind of discrete things. Okay, so an arithmetic sequence is where the terms have a common difference. So for example here, we're adding 3 each time. So you might have heard it called a linear sequence, something like that, which is fine. So a few bits of more notation. Sorry, this should say U1. So the first term U1 we often just call A, the number of terms N, the last term L, and the common difference D. Okay. So to come up with some formulae, we're going to kind of consider a sequence and consider what all the terms are in terms of A, D, and stuff like that. Okay, so our first term in this case, our U1 or A, is 5. And then let's think about how do we get to the next term in terms of our common differences. So our second term is the first term plus the common difference, which is 8. Our third term, we've had to add on another common difference to get 11, etc. So the fourth term, we've added on 3, etc. So if we wanted, for example, the 100th term, we'd have to do the first term plus 99 lots of the common difference. So in other words, whatever term we want, we start with the first and add on one less lots of common differences. So in general, if we want the kth term, we're going to use the first term plus k minus 1 lots of the common difference. So that's your first formula really for that. Now, we could also imagine L, our last term, would be un because we're assuming there's n terms in the sequence. So that would be A plus n minus 1 lots of common difference. Alright, so those are two important formulae that you're going to need answering questions. Another one is going to be one for working out the sum of a sequence up to a certain point. So let's imagine in general a sequence is going to be A plus D, A plus 2D, all the way up to, so it's going to say, for example, let's add in some pluses there. So we have A plus 3D, A plus 4D, up to A plus n minus 2 lots of D, up to the last term is going to be A plus n minus 1 lots of d. Now if we do what Gauss did, if we imagine flipping this sequence round and going backwards, so in this case now the first term is going to be a plus n minus 1d plus a plus n minus 2d plus a plus n minus 3d, and that's going to go all the way down to a plus d plus a at the very end. So now let's do what we did before and add up each pair of these terms, if we can imagine them one above the other, running our colours, and think about what our totals would be. So we've got, this would be 2a plus n minus 1d. The next one, we've got 2a again, and we've got n minus 2 lots of d plus a d. So we've got n minus 1 d. So you can see a pattern forming here, just like when we had 101 for Gauss's. So here again, 2a plus, we've got n minus 3d, but plus another 2 brings us up to n minus 1. And the same thing happens for all the other terms. So here we've got 2a plus n minus 1d, and finally another 2a plus n minus 1d. So if we think how many of those we've got in total, we've got n lots of 2a plus n minus 1d. But again, just like with the very first problem, we've counted this twice. So the sum, some more notation, the sum for the first n terms is going to be a half n times by 2a plus n minus 1d. Another way you could also think of this, which is often useful, is if we split that up into a plus n minus 1d, notice that this is our formula for L, the last term, so we can also think of it as a half n times by the first term plus the last term. Okay, good. So that's what those all look like. So this is exactly what you will see in the first page of your formula book if you're doing MEI. They've got the kth term, the last term, which is the same but with a k, and then your two formulae for working out the sum up to the first n terms. Okay, so let's try and solve some problems using this. So first of all, there are 20 terms in an arithmetic sequence, so we know n is 20. The first term is minus 5, and the last term is 90. So first of all, what is the common difference? So we've got to use a formula that's going to link all these together. Now we know that the last term is a plus n minus 1d. So subbing in what we've got, L will equal minus 5 plus 19, because that's n minus 1, d. So 95 will equal 19d, therefore d equals 5. And then find the sum of the terms in the sequence. So we want the sum of the first 20 terms. Because we've got the last term, we can use that kind of easier formula that's like this. So we could use the other one, but this one's just a bit simpler. So a half n is going to be a half of 20, which is 10, times by minus 5 plus 90. So that's going to be 10 times by 85, which is 850. Okay, good. Okay, so 4 more problems and then I'll leave you alone. So the fifth term of an arithmetic sequence. I think it's always good with these to write down what they're telling us. So U5 is 28 and U10 is 58. Find the first term and the common difference. Now some people can do this kind of intuitively and they can think, well, what have I had to add on if I'm going along 5 terms? But you can do this all based on the formulae. So we know U5 is A plus 4D, and that's 28. And we know U10 is A plus 9D, and that's 58. So you can see we've got simultaneous equations now. So what I'm going to do is take away the top term from the top equation from the bottom equation. So I'll get 5D is 30, and that means that D is 6. And now if we want to find the first term, we can sub back in. So the first term plus 4 times the common difference that we now know is 6 is 28. So a plus 24 is 28. So a must have been 4. And then it says the sum of all the terms in the sequence. So I'm assuming that then means we want the sum of the first 10 terms, because that's the kind of latest one it's talked about. So that's going to be, now once again we know the 58, we know the last term. I'm going to use the other formula just to show you how it works. And I've missed that off. So a half n is going to be a half of 10, which is 5, times by 2a, so a was 4, so that's going to be 8, plus n minus 1, n is 10, so that's going to be 9, times by d, which is 4. Okay, so 8 plus 9 times 4 is 44, times by 5 is 220. Right, lovely. So the next three are all exam questions, and just to give you a sense of some of the notation, the kinds of things they're going to ask you, these are all section A questions. The section B ones tend to be geometric, but you can find some arithmetic. So the second and third terms in the sequence are given by u1 is 5 and un plus 1 is un plus 3. So what this means is, if you're at the nth term, if you want the n plus 1th term, i.e. the term after that, you take your term and add 3. So for example, if u1 is 5, u2 is going to be u1 plus 3, so that would be 8. So 5, 8, 11, 14, etc. Find also, so first of all, find the second and third terms of our sequence. So the second and third terms would be 8 and 11, so that's u2 and that's u3. And they also want the sum of the first 50 terms. So now we know a is 5, we know d is 3, so we've got enough information to do s50, which is going to be a half n, so 25, times by 2a, which is 10, plus n minus 1, so 49, times by d, which is 3. So 10 plus 49 times 3 is 157, times by 25 is 3,925. Okay, right, the 11th term of an arithmetic progression is 1. The sum of the first 10 terms is 120, and they want us to find the 4th term. Okay, so let's think what we know. u11, which is a plus 10d, equals 1, and s10, so let's think about the formula for that. That's a half n, which is 5, times by 2a plus n minus 1, so 9d, has to equal 120. So again, we've got two simultaneous equations. So 10a plus 45d equals 120. And let's divide that all by 5 to make our lives easier. So we'll have 2a plus 9d equals 24. Okay, so we're going to double this second equation. So we've got 2a twice, plus 20d equals 20. No, it doesn't, equals 2. And then I'm going to take away the top from the bottom. So 2a minus 2a is nothing, good. 20d minus 9d is 11d. 2 minus 24 is minus 22. So d is minus a half. So it's going down by minus a half each time. And we also will want to know the first term, so I'm going to sub that back into here. So a plus 10 times minus a half is 1. So a minus 5 is 1. So a is 6. So now we've got enough information to find the 4th term, which is going to be a plus 3d. So 6 plus 3 times minus a half, which I want to say is 4.5. Yeah, okay. Right, so last question. The 7th term of an arithmetic progression is 6. The sum of the first 10 terms is 30. Find the 5th term. So we can see this is pretty similar to the last one. They're not that creative over at MEI. So a plus 6d is 6. And then 5, so that's a half n, times by 2a plus n minus 1d is 30. So this is going to be 10a plus 45d, remarkably similar to the other one, equals 30. And then divide everything by 5. So 2a plus 9d is 6. And then I'm going to double the first equation and write it underneath. So we get, if we take off the top again, 3d is 6, d is 2. Sub that into the next one, we'll have a plus 12 equals 6. So a is minus 6. And then we can find the fifth term. So u5 will be a plus 4d, which is minus 6 plus 4d, which is 8. So we get 2. Alright, so I hope you found that useful. As always, any requests, please let me know. Cheers.